Okay, when solving stoichiometry problems, I just wanted to give you some hints and some guidelines to follow so that you could solve any stoichiometry problem. So, stoichiometry problems are any problem where you are given an amount of one substance and you are asked to find an amount of another substance. So it doesn't really matter whether this initial substance is a reactant or a product, and it doesn't matter whether you're trying to find an amount of reactant or product. All of these problems are solved similarly. So we're going to start with a generic reaction. This is not a real reaction. There's no such thing as element A. So it's just standing for some substance, and X is standing for some substance, and we're making a new compound A2X3. So the reaction is balanced, and that's a requirement, of course. But we have to remember that this is basically like our standard recipe for making this new substance here. And the standard recipe is always written in terms of moles. So it really means, as written, 2 moles of A react with 3 moles of X, whatever those substances are, to produce, the coefficient here is 1 mole of A2X3. So this is the information that we get from the balanced equation. So let's say that we are given 62 grams of X is going to react with excess A. So what that means is you don't need to worry about this substance here. You're going to have plenty of it. You're not going to run out of it. The question is, if you start with 62 grams of this, how much product can you make? So you should recognize, if you've read several problems in the homework, that this is normally how they read. You are given one quantity and you're asked to find another quantity. Alright, so the setup for these is always going to look the same. You're going to start with the given quantity, which is, in this case, 62 grams of X, whatever it is. And the first step of the stoichiometry problem is always to convert to moles. This will be the same for every stoichiometry problem. What relationship should you use here? We're converting grams of a substance to moles. A hint, this will be a 1 always. And to convert grams of an element, maybe this is an element, maybe it's a compound, we need the molar mass of X. And that, of course, can be found if you reference your periodic table. So the first step is to convert grams of the given substance to moles. We are doing that because the standard recipe is moles. That allows us to then continue our dimensional analysis and convert moles of X, the given substance, to moles of the substance we're trying to find. We are interested in this case, the product A2X3, whatever that is. This step is critical in a stoichiometry problem. It allows you to convert one substance to another, and this will always be done with units of moles because that's given in the standard recipe. This is a real easy step. You just have to know to do it because the information that goes here comes directly from the balanced equation. The relationship is 1 mole of A2X3 is related to 3 moles of X. So those values will go right into this critical step of a stoichiometry problem. So our relationship is 1 to 3. That comes straight from the recipe or the balanced equation. Okay, now we're ready to continue on, and notice now we're working with A2x3, whatever that is. We would like to know what mass of it can be produced. So we're converting back to grams. This will be a 1. And again, this is just a gram to mole conversion, so we're going to use molar mass. And this time, it's not the molar mass of X, like it was over here. It's the molar mass of A2X3. So we would look up these values on our periodic table and sum them up. All stoichiometry problems will be set up exactly like this. So if you're getting them wrong, chances are you've miscalculated a molar mass, or maybe you have the values from your balanced equation flipped. This is the primary reason why we learn how to use dimensional analysis in a much earlier chapter, so that we can tackle some problem solving like this.